Good morning, good evening, wherever you are, and welcome to episode 97 of the Cloudcast. We're coming to you live from OSCON here in Portland, Oregon, and today we have Cloudcast alumni on the show. We're going to talk a little bit about application containers, and so returning to the show, we have Solomon Hykes. Is that how you say your last name?
That's exactly how.
All right, CTO at dotCloud, and also joining is veteran to the position of, 4 days now?
4 days. I'm 25% smarter today than I was yesterday.
There you go.
Yeah.
Ben Golub, who is newly minted CEO at dotCloud. So, Solomon, you and I, what was it, episode, I want to say 66. It was at the AWS conference last year. We sat down and talked about dotCloud as platform as a service offering. But you've had a bunch of stuff going on since then. So first of all, hey, welcome to the show.
Thank you.
But tell us a little bit about what you've been doing.
Sure. Well, so something very significant happened for us at dotCloud. At some point late last year, we decided to open source our core technology. First as an experiment, and when we finally proceeded and opened up the code, it was so successful so quickly that it forced us to kind of reevaluate our priorities as a company, because this new project, Docker, grew a community that was so active so quickly that there was no way we could support it properly as only an experiment, right? And so that is the big thing that happened to us since last time. We essentially became the company that supports Docker, which 4 months after being released has received contributions from 100 different people, has thousands of GitHub stars and tens of thousands of downloads, etc. And so it's a big change for us. It's really exciting, becoming a full open source, open design company, and it really opens up the scope of what we can do and who we can help out there.
Sure. And so to give everyone kind of a background. dotCloud started out started out now, right? Started out as basically a PaaS company, but with Docker. So do you call it Docker or Docker.io, first of all?
Docker.
Okay, so Docker is really around this concept of application containers. And I completely agree, because it's certainly something you're seeing from pretty much all of the vendors that are out there. Of this is kind of the next big thing, and so I attended your session. I was like, well, I need to go catch up and probably need to prep a little bit. So I attended your session, and first of all, you were, when I say the room is packed, well, everyone, is it a little room or is it a big room? Big room, right? You were in one of the big rooms, and it was packed, and you were kind of a rock star afterwards too, because you were like, guys, I got to leave the room. They're kicking us out, right? So there was definitely a lot of interest in there, and you have cool stickers too. So, but it wasn't just the cool stickers, and actually I got one. Yeah, I put it on. But give everyone kind of a quick summary of Docker as a product and the concepts that you introduced in the session.
Sure. So the short version is that Docker is what we call a container engine, and its job is to make it easier to ship code to the server, right? And the premise is that should be easy, but it's hard. It's not reliable. It's brittle. It's labor intensive, and the main reason behind that is that increasingly, as a developer, you have to maintain a software stack that is large, complex, loosely coupled. It's typically not based on a single language or framework or library anymore. It's kind of all over the place, but you still have to manage it as a whole. And at the same time, that stack needs to be deployed and shipped to an increasingly diverse and large collection of infrastructure components, right? So it's supposed to work on your laptop. It's supposed to work on the QA server under the desk. It's supposed to work on OpenStack, on EC2. It's supposed to work on an appliance that you ship to the customer. So you have this matrix of hell, right?
Yes.
Where every row is a software component and every column is an infrastructure component. and you have this horrible multiplication of problems. And it's your job as a software developer, as an ops guy, as a DevOps guy, to make sure that every intersection of that matrix somehow works. And that's very hard.
Yes.
And I think today we have a large collection of tools that make it easier to cope with a matrix. So I think of them as painkillers. You need them, but at some point you got to start thinking about making the problem actually go away. And that's what we're trying to do with Docker. And the analogy we use is that of shipping containers. Right? The shipping industry had the same problem. They had lots of stuff to ship on all sorts of infrastructure, same matrix.
So the big boats, the big trucks, the big everything with the big shipping containers, you take a crane and you just kind of go chunk.
Yeah, exactly.
Move it over there. Right?
And so you got the key concept that we're pushing is separation of concerns. Separation of concerns is really the number one thing, because the developers have their concerns. They wonder about what's the best language, library, build tool, test tool, and infrastructure people have their concerns. What's the best storage? What's the best scale-out mechanism? What's the best automation, monitoring? And it's hard enough to figure these things out. If they're coupled, then it becomes really hard. So really, Docker delivers that separation of concerns through this standard format that both sides can agree on. So developers, regardless of what they use, end up packing up a container, and then infrastructure people, regardless of how they do it, end up shipping and moving and deploying containers.
Sure. And how is probably the number one, actually two number one questions. Is that possible? One number one question that came to mind was, okay, so how is that different from just virtual machines and cloning of virtual machines?
Yeah.
Create an image, create a template.
Yeah. So I think the short answer is, virtual machines are part of the infrastructure, and they are very useful as an element of infrastructure. I don't think we're ever coming back from VMs, but as a unit of software delivery, they're not practical. Developers typically don't use them if they can avoid it, because I can't ship you a VM and trust that you'll be able to run it the way I want it everywhere. Right? You may use a different VM-based system. Right? If I ship you a VMware image, it's not going to work out of the box everywhere. You may not be using VMs at all. Right? There's a lot of bare metal deployments out there. We see a lot of situations where an organization has a really sophisticated, automated VM deployment system, but the development team doesn't have access to it. They can't just spin up VMs. And so they're stuck without the ability to deliver things. So I'd say, the short answer is VMs are heavyweight. They're better for infrastructure, and containers are better for software delivery. But they can work together.
Sure. And I liked the analogy used in the session of, it's once upon a time virtual machines were a hammer and everything was a nail, right? And I do believe in that more and more. And that kind of goes into the container discussion for a little while of, again, you're abstracting every layer of the hardware. And actually, I was in Simon Wardley's talk yesterday, and Simon tends to be just this huge big picture thinking. But one of the things that was really cool about what he was saying is you take a technology and it kind of moves to commodity over time, but then that always spawns something new, and then that kind of moves. And so we've almost reached that point where, and I think we have, where that virtual machine is a commodity more and more. Yeah. But at the same time, it spawns new needs, and how do you move up the stack even further, right, and make the next thing a commodity, right? And I think that application containerization is certainly probably that next area of major development in the industry. And so something in my day job I get a lot, and you're seeing a lot more of, is the concept of LXC or Linux containers. And so is dotCloud, is Docker LXC under the covers? And tell me a little bit about the underlying technology and how it all happens.
Yeah. So yes, Docker builds on top of LXC. Okay. And LXC has been used to mean different things, but fundamentally it's a set of features that have been added over time to the Linux kernel and make it possible to run processes on a Linux system in a highly sandboxed and isolated way. And these capabilities have been around for a long time. In other systems, Celeris has had it for a while. The BSD jails existed for a while. Linux for a while had weaker capabilities. You could chroot, things like that. But over the last couple years, these features have really been improved, and more importantly, they've been improved in the mainline kernel. So for a long time, if you wanted strong isolation of processes in Linux, you could do it. At dotCloud, for example, we've been doing it for nearly 5 years, but you had to patch the kernel, which means that you could not, you could, kind of like VMs, it required control over the infrastructure.
Right.
You couldn't assume everyone could run your container.
Yep.
What's changed is that now that Linux has containers out of the box, you have this critical mass of machines around the world that can run containers, whether they know it or not.
Yes.
Whether their owners know it or not, they can actually run containers.
And patching the kernel is often a showstopper for
Yes,
a lot of
is.
orgs, right? Now, and kind of dig even a little deeper. So for those that are unfamiliar with the concept as well, so LXC is often grouped with C groups.
Yeah.
So
there's a
what's
little bit of
what's the difference between C groups, right?
So actually, again, the definitions have moved around. As,
What is today's definition?
So I think it's fair to say that from the point of view of the work we're doing, which is there's raw capabilities in the kernel. Now let's make use of them. Let's make them useful to the engineering population. Right? So that there's a lot of work there. What's the right API to expose? There's a lot of ways to use LXC, which we don't think are the right way. Right?
Okay.
And so to answer your question, LXC is a sort of an umbrella term for actually a group of features, one of which is C groups.
Okay.
And another one is namespaces.
Okay.
And so I've been told the respective definitions and the relationship between the two has moved over time. But really, we just abstracted away and say LXC, and then we dig in deeper when we need to. But C groups has to do with resource accounting and limitation. This much RAM for this process, this much I/O for that one. That's C groups. And namespaces is not the process is not seeing each other. Right?
Okay. Awesome. Now, so that kind of gets us at the, if I use kind of even like the Amazon terms, that gets us compute. But what about from a file system level? The file stuff you're doing is actually really cool. You're almost layering on a filing system, and if I understand correctly, it's copy on write technology, so it's even kind of a minimal footprint.
Yep.
And then again, using that shipping container stack analogy, it is possible to stack containers on containers, correct?
Yeah. So that's correct. So that's another.
So it's like 10 questions.
Yeah. So let me sort them. We use a copy and write file system. The current implementation we use is AUFS, and by the way, there's been discussion about enabling other file systems, which we're working on. But yeah, the key feature is copy and write. And what that allows us to do is give you a fresh copy, a completely isolated copy of the file system every time you want to run something. Right? So that means you can run 10 instances of the same application process, and all 10 of them will have their own sandboxed file system. They'll have the same base. Yet these 10 containers, these 10 processes, will have been started in a total of 200 milliseconds, right, including copy.
Okay.
And that's because under the hood, we don't actually copy the whole thing. We do a copy and write, a lazy copy, using this file system.
Sure. And for listeners out there that aren't familiar with copy and write, it's basically, when you need to create a new bit, that's when you're writing it. You're not making a full clone up front, so you don't have overhead of disk space.
Yep. So the system tells you copy complete, but really it just created a new reference. And as you start changing files, then it copies gradually over time.
Sure. And so as long as they don't change very much, the difference between one container and 1,000 containers to start is effectively nothing.
Yeah.
Right? Because it's just a matter of, okay, if those 1,000 containers change drastically over time, then you've got a problem.
But you have, at the worst case is you have this. You're back to the same problem you had with VMs or copying, the full thing every time.
Sure.
And in practice, very little actually changes.
Okay.
And what does change, you have control over. So one feature that we added to Docker is that at any time you you can track which container was copied to which container, so you kind of track the history.
And so there is the concept of, even though there are containers and let's say they're, quote unquote stacked on top of each other, there is still almost tracking.
Yeah. So it's just like
if something was in container 1 and goes to container 2 or gets copied or modified or whatever.
Yep.
You have an auditing or tracking system.
You have a full auditing system, and it's a very important part of Docker. You basically have the equivalent of Git for containers. So you can, at any given time, you can point to anything running on any server and say, where did that come from? Oh, it was built from this previous common image last week, and you can layer that as many times as you want. So you can say, oh, this is yesterday's build of the app running on top of last week's Puppet build, running on built on top of last month's Ubuntu base system, for example.
Sure.
And you can always track that, and you can audit the actual differences. So you can always say, what's changed between this container and that container?
Okay. Now, so whenever I think about things like that, the one thing that automatically pops into my head, though, is chaining dependencies. And so can that become an issue over time of this changes in this container and this affects this container and that whole downstream workflow, right?
Yeah.
And is that something? How does something like that work if you get really brave and just start stacking
so
everywhere, right?
The key concept that makes it work is that containers can be frozen into images, and once they're frozen, they need to be frozen in order to be used as the parent of the next container.
So
right?
it's effectively a template,
and then they become immutable.
Yes,
and they get a big, long, unique ID, just like a Git commit. And from that point on, you have a guarantee that that's never going to change. So you can go back and say, this container is running that, and that whatever auditing you did yesterday is still valid. There's no in change.
So you could say it's almost like a snapshot point.
Yeah, exactly. That's exactly what it is.
And okay, very cool. Now, so we've covered a bunch of technology and what it is and what's going on. So, what are again, if you go look at the project, it's pretty explosive growth. So, what are the use cases typically? What kind of from a user standpoint or a developer standpoint? Why should you care? Right.
Yeah. So I mean it boils down to that matrix we were talking about. Developers today, needs a process for developing, testing, building, and handing to ops that is more automated, more reliable, and more lightweight. And so the dream, everyone's kind of aiming for that dream setup where you've got a VM in your laptop, or maybe you got a Linux laptop, so you don't need a VM. And you just develop, test. At some point, you like it, you just ship it, and it goes through automated testing, and it goes through staging, and eventually goes all the way to production, and it's exactly the way you built it. And as opposed to, let me change everything halfway through because this doesn't, it's not the same version of the libraries in the production servers. Oh, you've tested on Ubuntu, but we're in Red Hat in production, et cetera, et cetera. Not the right version of Python.
Right.
So just that ability to have a single, a single pipeline.
Yes, right? and because at the end of the day, you're really just, how do I put this? You're locking things or tracking things all at the file level, as opposed to at an application level. You almost have the ability to create libraries or chunks and make it components that you kind of chain together. Instead of okay, here's my entire stack and it is one big container, you have the ability to say, okay, here's my container for this function, container for this function. And then it gives you the modularity if you want to change something, or you pull out one container, replace it with another container, as opposed to replacing the entire thing. So it gives you some modularity on top of it.
That's correct. That's also a very big draw. It makes your code base, it makes it more practical to reuse components. Your own components across projects, but also someone else's components. And so one thing that ships with Docker is a notion of a registry. There's a public registry of containers, which you can download. And actually, to get started with Docker, the simplest way is to just download a starter image, either an Ubuntu system or a Red Hat system, etc., and then build on top of that. Or you can create your own. You don't have to.
Sure.
But then the really cool thing is any container you build can be uploaded back at any time to the registry for others to use. So if you search for Postgres or MongoDB or Rails or anything, you're going to find dozens of those components.
Sure.
And we're setting things in place for tracking quality, even things like reviews. So, you have to have a way to trust the source, who's giving you that.
Right.
But it's a really powerful mechanism because then you can just swap out your Postgres component and replace it with someone else's, and it'll work.
So, you bring up an interesting point there, and that kind of to shift focus here slightly. Very different kind of direction of the company at that point for you as well, because when I had spoken to you, dotCloud was really more PaaS based and more hosting, but this seems more of I can run Docker pretty much anywhere. It doesn't have to be necessarily. So you've almost gone from that service provider into a product as a shift as a company, right? And so, tell me a little bit about what that is like, because I'm sure that's not something that's super easy, or I guess if enough of the demand there, you just kind of go run in this direction, right? But it's not something that happens every day by any means, right?
Yeah, well, I think it's an exciting shift, and part of the reason why I was attracted to come over to dotCloud after having been CEO of Gluster. PaaS is a great business, but at some point, the problem with PaaS as a business is that your best customers leave you. So you can offer, as dotCloud did, a large set of different languages to customers, and say that those will run well on our infrastructure. But ultimately, everybody wants more languages than any one company could possibly provide, and they want to run it in more places than just your own infrastructure. As Solomon said, it's on a laptop, on a VM, on the customer's infrastructure, EC2, whatever the case may be. And so I don't think you could have any one company provide that kind of infinite language, infinite platform, infinite enterprise, infinite cloud PaaS, but an ecosystem could. And that's why I think Docker as an open source project is so powerful.
Yes.
So then the natural question is, okay, so you do this, you enable the ecosystem. How do you make money?
Right.
And
which was going to be my next question.
Well, it comes up. It comes up a lot. But I think this is also where the shipping container analogy works really well. In essence, we're giving people the ability to easily create, pack, and ship containers. But that naturally says, well, how do you track the containers? How do you make sure they're going to the right places? How do you monitor them? How do you give people the ability to either discover and use or sell if they want to? And so for us, one of our next major goals after we get the sort of product stable and widely used is to launch, if you will, sort of the GitHub to equivalent for Docker, where people can have a private registry, a public registry, buy and sell containers, and provide things like monitoring, orchestration, etc.
Very cool. Very cool. And yeah, so it's interesting because again, who was it that I spoke to earlier? Oh, Ansible. I spoke to Ansible Works earlier this week, and they kind of did the same thing of they started as a, hey, we're going to go do this because I just kind of want to do this and I see a need around it, right? And then they're like, we'll throw it out there and see what happens. And all of a sudden, boom! You've got suddenly it went from a weekend kind of fun thing to now I've got a project on my hands that all these people are interested in. Yeah. And then it's like, oh no, well, we might have something here, right? And then turning that into a new direction for a company is certainly something that's very fascinating.
Yep.
So
I would add that the reason, one of the factors that made Docker successful is that we made it based on our experience as a managed public PaaS. So it was built by a team of engineers who have to wake up at 4 a.m. to fix stuff, and
right.
they like cool drawings on the whiteboard like everyone else, but at the end of the day, we want it to work. We want it to work in real-world situations. And so with Docker, really what we've built is what we wish we had on day one of dotCloud, right? So there is that synergy between actually running your own servers and being responsible for uptime, and then shipping code. I think it's really hard to do one well without the other.
Sure.
Yeah. Well, one of the things that really excites me about the project is not only that it appeals to developers, but actually appeals to folks in DevOps and Ops as well. And I think, as Solomon says, the fact that it was built by a bunch of people who had to be both speaks to that. So, at this point, the developers are excited because they can, build something once and finally run it anywhere. Right. And the ops guys are equally excited because they say, well, we can configure once and then we can run anything. And that's really the power of the model.
Very cool. Very cool. So we are out of time for this week. So Solomon, Ben, where can everyone find out more about the project, the product, what's going on?
So the project has a website. It's on docker.io, and it lists all the resources you could expect. There's a GitHub repository. We are very, very encouraging of contributions, feedback. That was kind of our golden rule that every contribution, no matter how small, is welcome. Typos on the README, we'll thank you warmly. Just trying it out and reporting bugs or asking for improvements, that is very valuable. I've been scarred for life by unwelcoming open source communities, so that's our number one thing.
Sure.
Yeah.
Awesome. Also say that we have a ton of meetups that are scheduled.
Yeah. Okay.
In San Francisco, in Boston, in Austin, New York. Those are all also listed on the site.
Great.
And half of them are organized by people who don't work for dotCloud, which is also very exciting.
Very nice. Good. That's a great sign of the community. Absolutely.
Yeah.
Well, thank you very much. All right. If you like the show, please tell a friend or leave us a review on iTunes. You can follow us on Twitter @thecloudcastnet or on the web @thecloudcast.net, where you can find links to everything Cloudcast. Thanks for listening.